We are given a second order differential equation and we are supposed to solve for the general solution. So to do that, we will first need to find an expression for dy dx, and that will be integrating this. So integrating 2 over square root of 1 minus 4x squared is what we are going to try to. And for the denominator here, I'm going to re-express it as square root of 1 minus 4x squared. I'm going to write it as 2x squared. So it is going to be 1 over this, where this is going to be my fx. Let me write it down. So I'm going to be going for fx to be equal to 2x. And as for f prime x, it is equal to 2, which can be found here. So integrating this is going to be equal to sine inverse of 2x plus c. And now we can find the expression for y, which will be another round of integration. We will try to integrate sine inverse 2x plus c. So to integrate this, we are going to make use of integration by parts. So to do by parts, I'm going to let u be equal to sine inverse 2x. And I'm going to let dv dx be equal to the coefficient, which is 1. So for here, du dx is equal to 2 over square root of 1 minus 2x squared, which is equal to 2 over square root of 1 minus 4x squared. As for this, v is equal to integration of 1, which is x. So applying integration by parts for this expression over here, we will have a uv. So it is going to be x sine inverse of 2x minus integration of v du dx. So this times this, we will have a 2x over square root of 1 minus 4x squared dx. Then plus c, integrating it, it is going to be this. Then plus an arbitrary constant, let's go for d. So this is going to be equal to x sine inverse of 2x. And to integrate this, we're going to apply another round of fx f prime x. And that is when I'm going to be letting fx be equal to 1 minus 4x squared. And f prime x will be minus 8x. And we can see that here, because if I were to just move the negative in, which means that I'll have a plus here, and divide by a 4 outside, that will help me to create a negative 8 as a coefficient, multiplying by this x. We will now have our f prime x. And for this, I'm going to re-express it as 1 minus 4x squared to the power of minus half. And now we are ready to do another round of integration for this. And it is going to be plus cx plus d. So let's try to integrate this. This is going to be equal to x sine inverse 2x plus 1/4. Integrating this, it is 1 minus 4x squared to the power of minus half plus half. It is going to be, sorry, minus half plus 1. It is going to be equal to half. Then divided by half. Then plus cx plus d. So this is equal to x sine inverse of 2x plus half. This is square root of 1 minus 4x squared. Then plus cx plus d. And in this part, we are given that y is going to be equal to fx, which means that fx will take up the form of x sine inverse 2x plus half of square root of 1 minus 4x squared plus cx plus d. And in order for us to find a particular solution to this curve, we need to solve for c and we need to solve for d. We will make use of this piece of information here. The origin is also the minimum point. So the origin, which means that at the point 0, 0, it is a minimum point. So it is also a turning point. So at 0, 0, f prime 0 will be equal to 0. dy dx is going to be equal to 0. So we will have a sine inverse of 2 times of 0 plus c is equal to 0. Sine inverse 0 is 0. So c is equal to 0. And we need to solve for d, and to solve for d, we are going to make use of the fact that the curve passes through this point, which means that f0 is equal to 0. So let's replace all the x here by 0. So this, if I were to replace this x by 0, the entire term here is going to be 0, then plus half. This is going to be replaced by 0. So we will have a square root of 1 minus 0, which is going to be 1. So it is going to be half. And this is going to be equal to 0. Then plus d is equal to 0. This gives us d is equal to minus half. And now we have our particular solution for fx. So fx is going to be equal to x sine inverse 2x plus half square root of, basically I'm just copying this, 4x squared plus c is 0, so that term disappears, and d is minus half. So minus half. We are supposed to sketch the graph of y is equal to fx, and if you have had pressed that into your graphing calculator, this is the shape that you are going to be getting. And for the graph to be meant for fx, we want to make sure that x is going to be strictly between minus half and half. So at these two endpoints here, it is going to be from minus half to half. So I'm going to make use of a hollow dot to specify that they will not take up these two values. So we have these two hollow dot here. I know the x coordinate is going to be equal to minus half, and the other one is going to be equal to half. So to find the corresponding y coordinate, let's try to find out what is f minus half. So let's go for the y coordinate of this point first. So it is going to be equal to minus half. Then sine inverse of 2 times of minus half is minus 1. Then plus half of 1 minus 4, half square is actually 1/4. Sorry, minus half square is 1/4, which means that it will turn out to be 1 minus 1, which is going to be 0, then minus half. So we will have a minus half. Sine inverse of minus 1 is going to be minus pi over 2. Then this minus half. So this is going to be equal to pi over 4 minus half. So the y coordinate here is pi over 4 minus half. And let's find the corresponding y coordinate of this. I'm suspecting that it is going to be exactly the same as this, because from the calculator, they look like, they are going to be falling on the same horizontal line. Let's check and verify whether this is going to be so. So I'm going to substitute x by half, and that is going to be equal to half. Then sine inverse of 2 times half, that is 1. Then plus half of 1 minus 4 times half square, which is going to become 0. So this will become 0 again, minus half. So this will be half. And sine inverse 1 is pi over 2, and minus half. So once again, we get a pi over 4 minus 2. So the y coordinate of this is pi over 4 minus half. So pi over 4 minus half, and this gives us our graph of y is equal to fx.